All right. Okay, everyone in. Hello, everyone. Yep, this is Rinkeby, and I'm Calvin. This is the intro to Web3 talk. So yes, you are at the blockchain talk. Quick show of hands. Let's see everyone's experience level here. Who has actually worked with or familiar with blockchain? Hands up. Oh, hi. Great to see them. Okay, so about 2 of you. Okay, so yeah, double. So seems like the vast majority of you don't have experience with blockchain, and that's okay. We'll slow it down, and we'll make sure you guys understand most of the concepts as we go along. All right. Yes. So today, cryptocurrencies seem like they're up there with VR, AI, ML in terms of buzzwords, and a lot of money is moving around, which attracts a lot of people looking for profit. But there's surprisingly little content dealing with how they work. And there's a lot more to it than just magical internet money. Today, the underlying technology is actually pretty simple. And we'll go over in this talk how it works and how you as a hacker will start with it. Over the next hour, we'll be setting up a wallet, writing a smart contract, and writing a simple code. All these resources, including these slides, our speaker notes, and the sample code are available at that first. So let's get started. We'll probably get a show of hands as well. Who here is in high school? Show of hands. Okay. Who here is in first year or freshman? Okay. Who here is in second year? Hands up. Okay. Who here is third year and over? Okay. If you guys have questions, we'll have time for that. Please don't be shy. We'll be asking you guys to ask questions if you have any questions. Yeah. So, get to it. Yeah. So we have a bit of a bimodal distribution here. So we have to move slow and still move fast. So please bear with us if we're going either too slow or too fast. Yeah. All right. So Ethereum is basically a really slow computer that runs things in the sabotage basically, you can think of it as a system where everybody runs every published Ethereum program at the same time. And then they group up by the results of that computation, and one group manages to prove that it has the most computing power. That group's results are then accepted as the true results, and we'll get into the details of that in a bit. But if we assume that the majority of computing power generally belongs to honest people, then that group will almost always be able to win. The system offers incentives for everybody to agree with winning group, so everyone tends to converge to the same result. So users on the platform can then prove, so for example, a betting platform might publish a program that runs on Ethereum's computer. Users on the platform can then prove that the platform actually runs that code. So you can trust that the betting platform will actually behave according to that program's code. In other words, Ethereum allows users to trust that the betting platform isn't trying to sabotage results in their own favor. And the betting platform can trust that users aren't trying to sabotage the computer in their favor. Okay, let's go over what a blockchain is, first of all. A blockchain is conceptually very similar to a linked list. And as you recall, it has constant time append and linear time modifications. Okay, does everyone, if who here knows what a linked list is? Show of hands if you know what a linked list is. Most people maybe give a quick explanation. Okay, a linked list is a data structure consisting of nodes, which are structures that point to next nodes. So nodes point to other nodes in a linear fashion. And if you want to append something to the end of the linked list, what you do is you take the last node, which you have a reference to, and then you make a new node, and you make this last node point to your new node. If you want to modify something, you have to start from the beginning, and you go over to the place that you want to modify, and then modify it. And that takes linear time.
Okay, so a blockchain is a linked list where each node has a cryptographic hash of the previous node. So what's a hash? A hash is a way to summarize data, like a fingerprint for a person. So two people are very unlikely to have the same fingerprint. And that fingerprint kind of uniquely identifies the person. This is a very rigorous explanation, but we'd be happy to explain more afterwards if you're interested. But concretely, a fingerprint in our example is a 256-bit string of ones and zeros. Okay. Blocks are added to a blockchain. Similar to how you append to a linked list, you have a process called mining. To mine a new block, people create a skeleton of a block, and then they keep modifying it in cosmetic ways until its hash, which, as you recall, is a fingerprint for the data, a string of bits, ends up starting with a certain number of zeros. Essentially, in this example over here, this block 2, to mine block 3, we have to generate millions and millions and millions of blocks based off block 2 until we find one that has a fingerprint that starts with the right number of zeros. And this is a process that's very difficult to computationally do. But basically, the process involves just repeatedly trying things until it works. There's no faster way to do it. Okay, after you have that new block, you can append it to the linked list right after block 2, so now you have block 3, and the result will be a new linked list where all the hashes match up and all the hashes begin with zeros. And those are the two conditions for a valid blockchain. So this linked list is a blockchain. That's it. That's what a blockchain is. Actually, it's not our presentation. The cool thing about this data structure is if you have a big group of people and you all agree on what block 3 is, then you also have to agree on what everything before block 3 is. The properties of the fingerprint, which we didn't discuss, but we can later if you want, they ensure that if you change anything before this, and you don't change block 3, it's no longer a valid blockchain. And this makes it really easy to agree on huge chunks of data, like, for example, the entire transaction history of cryptocurrency, or other things that we'll talk about too. All right. So a blockchain by itself, it's just a data structure. It's how you use it that makes the difference. One way to implement a blockchain is to only allow one party to have absolute control of it. So, for example, if you guys are aware of cryptocurrency Ripple, that's an example of this proof of authority scheme. One person controls the entire blockchain. You get some of the benefits of a blockchain, such as over a normal database, such as integrity checking and maybe like transparency benefits. But there's actually much more interesting things you can do with this. For example, one particularly interesting application is to use schemes like proof of work or proof of stake to ensure that people can essentially vote on what blocks to have. And they vote using leverage such as their computing power or like the number of tokens they hold to cast their vote. So once you have this voting system in place that allows you to choose like democratically which blocks to add to the blockchain, you're allowed to build a system without a single point of failure or a single point of corruption. And this is especially useful in things like the cryptocurrency space. Let's talk about proof of work a little bit more, because that's the scheme that Ethereum is using right now. Although they're currently trying to transition to proof of stake. All right, so proof of work. There are some situations where you have a node seeing multiple blockchains at once, like blockchains that diverge from each other, probably because one group is trying to do one thing and another group is trying to do a different thing. This can happen legitimately when two computers both manage to append to a list at the same time. You get two different lists with two different results. Or when like somebody's trying to attack the blockchain, they'll try to mine a different chain sometimes. When this occurs, what we do is we accept the longer chain as a canonical. So if this chain had 4 entries, like block 4, and this one only had block 3, we choose the one with block 4 instead. The reason for that will become clear in a bit. So, as I mentioned earlier, an Ethereum block is valid if its fingerprint, the hash, begins with a certain number of zeros. And we modify this block skeleton until it starts with that number of zeros. Like we keep trying different possible blocks over and over again until it has that many zeros. Let's talk a bit more about how that actually works. Each block, this node in the linked list, has a field called the nonce. And to mine a block, what we do is we keep trying different values of that nonce, like 0, 1, 2, 3, 4, 5, 6, 7, and so on into the millions and millions or billions, until the resulting hash has that property, like the hash of the whole block ends up having that many zeros. On average, if the hash needs to start with k 0 bits, then each attempt has a 1/2 billion chance of actually resulting in a block that has that property. So Ethereum as a system will automatically adjust the number of zeros that you need to find until that process takes roughly 10 to 20 real world seconds. So no matter how much computing power is in the network, it'll adjust itself until it takes that long. So the longest chain is the canonical one, as we said earlier. If you see multiple ones, you just pick the longer one. And people get money when they extend the chain that everyone else accepts. So the result is people are kind of incentivized to append to the chain as fast as possible in kind of like a competition between computers. And this allows them to earn as much reward as they can. So people essentially get paid for appending to this data structure, assuming that you trust the data structure. So this competition to append to the chain makes it possible for the number of people trying to make an honest living to outnumber the number of people trying to attack the chain. So this competition makes it infeasible for malicious actors to catch up to the honest people, since we assume there's a lot more honest people. All right, so let's get to that. All right.
Maybe let's pause a bit here for any questions. Anyone confused by anything? Feel free to raise your hand and ask.
Any questions, anyone? Yes, you're over there.
What do you mean by attack a chain?
Okay, I guess we'll go over this after all. All right, is this right? This is right. So, say you want to modify, excuse me, say you want to modify the blockchain and get everybody else to accept that modification. This actually takes 15 n seconds, where n 15 seconds is the number of times amount of seconds that it takes to change to mine a new block, and n is the distance back that you're trying to modify. Okay, so we know appending definitely takes 15 seconds because that's how long it takes to solve that fingerprint puzzle that begins with that many zeros. It's 15 seconds because, by definition, the system changes. Okay, so we know that. But imagine you're an attacker and you're trying to modify the blockchain about. Say you want to give yourself more money by changing the transaction amount, like somebody paid you $5, you now want to change that to $50,000. That's your goal. You want to change that value. So the first thing you do is you actually make that modification. So now you started with data, now you have modified data. But what's wrong with this result? It's no longer a valid blockchain because this hash no longer matches up with this block. So this is an invalid blockchain. So let's say you change that hash to match up. Now this block changed, so you have to modify this block. And this block changed, so you have to modify this block. And it goes all the way to the end again. Basically, in general, modifying any block requires all subsequent blocks to be modified as well. But what else? We have to modify the hash as well. So once you modify this, the hash probably no longer starts with k zeros again. So you have to mine that entire block again by trying all the nonces, so 0, 1, 2, 3, 4, like billions and billions of times. And this will take 15 seconds, as you saw before. In fact, if you want to catch up to the original length again, it'll take 15 seconds times the number of blocks that you have to run. And in the meantime, the original chain just keeps growing longer and longer. So in fact, to catch up to the original chain, you have to have more computing power than the entire rest of the network combined. Which means, since there's so much computing power, you need to spend hundreds of millions of dollars to buy more GPUs and catch up to the rest of the network. And they're probably spending more on that. That makes it really expensive to modify the chain, and most people don't bother. You need to be really rich.
Anyone have any other questions?
Yeah, so one thing I get confused with, it's like if three person in like a network, so you have ABC, and B pays $50 to C, right? So this would be a transaction. But you said now you need computing power to like build a new block. But what if I don't have this computing power? What happens to the transaction? It's just like it's never official. Like I have to pay someone like $50, but it's never official because it's never been appended to the blockchain, or?
Well, you're actually very close to what happens here. So the people who are actually appending to the blockchain, they're called miners.
Yeah.
And there's a relatively small number of them compared to the number of people using Ethereum. So you, as a user, you would publish a transaction, which is like an authorization to pay somebody.
Yeah.
Kind of like a, what do you call it, a cashier's check.
Yeah.
And you publish that to the entire network.
Okay.
And a miner would see that and say, okay, I'll include this in the next block that I append to the blockchain. We'll talk about this later too. And what you include in your transaction is a cashier check to the person that you're sending money to, and it also includes a cut for the miner. So whoever picks it up gets this money. So the miner is like, okay, I'll get $5 or like 1% for including this block.
So I cannot have a blockchain system without miners. I always need a miner.
Not necessarily, but the ones we're looking at today will require miners. Yeah. For example, what's one that doesn't require miners? Can't think of one.
Well, the private blockchain require miners.
Yeah. Any private blockchain would not need that. Okay. We'll talk about that in a bit.
Okay, thank you.
Anyone have any more questions before we
I have a question about hash pointer. Because the second block has a hash of the first one, right? And I think supposedly there's a hash pointer pointing to a previous block, right? But in this graph, the pointers go back. Are there double pointers? Is the first block pointing to the second block other than the first?
So the arrow here means time.
Oh, I see.
So as time goes on, you get more blocks.
Right.
But the actual hash is pointing this way.
Right.
This is a hash of this, and this is a hash of this. Does that?
Yeah.
Any more questions? Anything at all? Does it matter how simple it
get
is?
into Oracle trees or Rinkeby? Anyone have any other questions?
Don't be shy.
Yeah. I want to make sure you guys understand this before moving on.
All right. Everyone good? Sounds good. So you're up.
Okay, so recall how Anthony was previously talking about appending to the blockchain. Miners need some kind of incentive in order to do that. After all, what do miners do? They have to spend tons and tons of money on hardware resources. So for Ethereum, GPUs, for Bitcoin, ASICs. And they also need to consume a ton of electricity. Hence, maybe you might see in the news that, oh, China has these huge mining farms and all this stuff. Maybe a reason for that is because electricity is cheap there, well, relative to other countries, so they turn that electricity and computing power into cryptocurrency. So miners need this incentive, and as Anthony said, as they successfully mine blocks, and these blocks are accepted by the network, they get a reward in the form of cryptocurrency. So in our case, Ethereum. Now, why this cryptocurrency has value to people, we're not totally sure either, but that's for another talk for another time. So don't come up asking us, oh, is ETH going to go up or down, or we don't know. So recall that 2 slides ago, you see in brackets data for every single block. So what does that data mean, right? Data has to be something, but what is that something? In our case, each block in the Ethereum blockchain has to store a bunch of Ethereum balances and, as we talked about before, transactions, and also the hash of the previous block. But what else can it store? Data can also include something very interesting, EVM bytecode and program storage. So what is EVM? EVM stands for the Ethereum Virtual Machine. And also recall how we define Ethereum as a global, distributed, trustless computer. So EVM is the computer part of all this. EVM bytecode does things like arithmetic and mutating state, and this actually creates the foundation for smart contracts. Show of hands, who's actually heard of smart contracts before? Like, has heard the term? A couple of you? Okay, good. Okay. So,
does anyone have any questions at this point?
Yeah, before we move on.
Cool.
Okay, and we'll explain smart contracts in a bit.
You'll be running on this one.
Yeah.
If you want. You don't have to.
Okay, so yeah, smart contracts. So this smart contract code gets run in response to transactions sent to it from externally owned accounts. So you might be wondering, okay, smart contracts, where did they come from? You can actually create your own smart contract using a special type of transaction. So there's 2 kinds. The first is obviously the normal kind, where maybe I send Anthony 3 ETH. And then there's a second kind where you use a special type of transaction to deploy your smart contract.
So you're uploading code into the Ethereum system.
You can also choose to run parts of an existing contract by sending a transaction to a contract. But that's a lot of scope for this. Okay, so maybe let's take a step back for a second. What do we get when we combine a system that runs code on top of another system that also ensures that everyone agrees on the results of this code? Essentially, we get a computer, one that everyone agrees on the results. Again, recall how we called Ethereum a distributed trustless computer. So you can actually program this computer using smart contracts, using languages like Viper and Solidity. And in the end, the code that you write in those languages are compiled down to EVM bytecode. So that's how you can write your own smart contract.
That's code for the computer in the computer part of Ethereum.
So you might ask, okay, so why would you want to deploy a smart contract? Why would you want to use this? So we'll give you an example, which is gambling. So say we all have a lottery, we all buy a ticket, but we need some trustless way to determine the results and determine who wins, right? Because, you know, in the real world, we all have incentive to try to sabotage the system and to try to steal from the lottery.
So if one person owns the computer and they also bought the lottery ticket, then they probably want to sabotage the computer to make themselves win.
So in our example, where let's say we have a smart contract that enables people to buy tickets and create a pool of crypto, and so everyone gets a ticket with a bunch of numbers that you choose, or maybe they're randomly generated, just like a real lottery. And the contract in the end, after aggregating this pool of cryptocurrency and everyone's tickets, it'll create random numbers. And then whoever has the winning ticket that matches those winning numbers will effectively win the whole pool of cryptocurrency. So as we said before, we need a trustless system for this because we can't trust anyone not to sabotage the results. So if someone on the computer like a centralized entity of some sort, they could effectively sabotage all this and take all the crypto for themselves. So everyone can be sure that the results are what they agreed to. So if my numbers match the lottery, I will get the pool of cryptocurrency. If they don't, then I don't get anything.
And you can draw an analogy from that to the lotteries in the real world, where you have a party like the Lottery Authority in Ontario that everybody trusts to do the right thing. In this situation, there's no party that you can trust. So the Lottery Authority doesn't exist. But we can still make an equivalent kind of application. All right, so time for the workshop part of this. If you guys want to follow along, the link to this is hypotenuse.ca/intro-2-web3. So if you're interested in deploying a smart contract right now, right here, we can do that together. All three of us will be, third person is over there. All three of us will be helping out, going around, and answering any questions that you guys might have. But basically, these are the steps. So let's go through the results. Sure. Okay, so at any point, feel free to speak. This is the hands-on section. All right, so what we're going to do first is install MetaMask. That's metamask.io. We're just going to go to the website, get the Chrome extension, back to Chrome. Can I install this? Can I install this? Actually, you need to get the ether.
Yeah. Maybe we'll just get everyone on MetaMask and then we'll just go around.
Okay. So let's install this extension if you want to follow along. If you guys, I don't know, couple minutes to install.
Has anyone, has anyone ever installed a Chrome or Firefox extension before? Probably shouldn't be asking this at a hackathon, but you don't know. Okay, everyone okay?
All right, so that's the MetaMask extension from metamask.io. It works with Chrome and Firefox. Okay, so let's stop now. All right, does anyone need help with that? Go around, like installing and setting up the extension. So I'll take that.
MetaMask.io. Everyone doing okay?
Everyone good here? Yeah. Oh, that would be problematic. So your Wi-Fi is hacked, right? Yes.
Yes. The Wi-Fi went down? That's hilarious. I think most people are okay. Just restarted.
If you guys need help with anything, just raise your hand in class. There's a bunch of us.
Yeah. Okay.
Everybody doing all right here? All right, just raise your hands if you need anything. We've got lots of time. Yeah. Everyone's doing all right. It takes a bit of time to get set up. So once you're done, you should have something that looks like this, except maybe without the money in it. This is not real money. This is, you'll notice we're on the test network. This is a network where you can get fake money from a fake bank and make fake purchases. Just like in real life. It's called Rinkeby. There's multiple different test networks that are in common use. This is the one that was there. So let's just look at Google Docs. And we should have some way to just post it on Slack. Yeah, we can post it on Slack too. There's a channel. Maybe that should be Slack. All right, so we'll be posting a link in the Ethereum channel on the app and on Slack. Let's post this link. Just follow that link. There'll be a Google Doc. Paste your public address in there, and we'll send you something. Like $20. So this is in the Ethereum channels on the app and on Slack. All right. If anyone is having any trouble at all, please raise your hand. Tyler, can you put it up on the screen as well? Yeah. Like the sign here. Okay. Oh, you got it. Sweet. And can you start sending it to people?
Okay. Excited to get your free money.
Rinkeby.
How are you guys doing? Everything good? All right.
Hey, what's up? Oh, you just create a random password. Don't use a real password. Just do like 123 123 123 or something. And yeah, and then go on to the Rinkeby test network, and then I'll give you that free money. Oh,
Hey, Melvin, can you start sending people leave?
yeah, it will.
Are you guys doing all right? Anyone else need help? Good?
Oh, no. That's your opinion. I really hope you didn't do this.
Everyone doing all right?
What do you mean I didn't do
As in, just, you never know. Crypto world is like, you should be fine. You should be fine if everything's tremendous, but just saying, never give anyone your private key in real life. Yeah, so this is just a test account, that's okay. And then make sure it's, awesome. Yeah.
All right, we'll start sending out the ETH right now. I'll take.
The links that we posted are just up there, so you can just do you have that? Yeah, they're the same. Yeah. Sorry about that. Wish we had a better way to just give everyone. That's
All right, I'm sending each person $11 worth of these.
free money, guys.
It's not actually worth anything.
Free money, guys. Hey, what's up?
Password I sent you.
Don't use the real, just use like 1, 2, 3. It's just like a test.
So once it's sent, it'll take 15 seconds to mine a new block, at which point you'll see it. Up to 15 seconds. Actually more than 15, up to 30 seconds.
Yeah, so are you set up on that? Yeah, so there should be that time.
There's no free lunch. You have to pay gas for every transaction.
Yeah,
Is it real gas fee or fake?
It's just all fake gas fee. You're not spending any real money. We're not spending any real money.
If you were actually
It's on the Rinkeby test now.
You'd be paying a little bit of to buy to include. It's kind of like,
How did you get a fake?
what's that?
How did you get a fake?
Post on Twitter.
Yeah, we just, there's this, for the fake network, there's this thing called the faucet. And the faucet is a website that acts like a bank. It sends you free fake Ethereum, Ether, in return for like, say, give me Ether. There's a website where you press a button that says give me fake Ether. Fake Ether isn't worth anything, so we don't just give it out for what it is. So I'm sending out the, okay, well, maybe you can work from the bottom up. And I'll work with the send. I told them to switch.
There's also
And the link is already, I mean, in the website, it has all the exciting thing. But we'll paste it again in this document and sure.
You were talking, right? And she just showed us this. I thought that was related to what you were saying. So I was looking at you like, what's that?
Yeah, we're pretty good.
Anyone else have any questions? Make sure you're on the Rinkeby test network.
Show them how to change the network.
Oh, yeah, sure.
So if you're in the extension, just go down to the network drop-down menu and go to Rinkeby. This is the test network where everything is fake. It's not real money. Don't worry if you lose it. We'll just send you some more. Also in the Google Doc, if you see sent by your address, that means we've sent you about $11. All right, makes sense. We're going to keep going down the list.
So what do you do for Rinkeby?
Yeah, so open up your MetaMask extension and then go to the top bar over here.
Oh,
And there should be a drop-down menu telling you, there's main, that sort of thing. So go to Rinkeby.
Right.
Paste the next
Good progress. It's a very manual process. Probably should have written something to make this easier. But we finished this at 4 a.m. today, so don't expect too much.
Yep. So we just posted 4 links. One will lead you to the Remix IDE, and that's where you can write your smart contracts.
Basically, copy and paste the code from this into this IDE.
Yeah.
And we'll show you guys what to do in a second.
Yeah. Enjoying your free money.
Congratulations.
You win.
You won.
You click. Sorry.
what do you do after your
Yeah, we're gonna get to that.
Yeah. Sit tight. Okay, so everybody who has sent by their name should have gotten ETH by their address and name. If you have not gotten ETH, let us know, we'll send you more. It's called throwing good money after bad.
Happens a lot. Yeah. Remix should look something like this.
Oh wow, there are actually a lot of addresses here. This might take long.
Okay.
Yeah, can you work on the bottom? So each one will take about 15 seconds. To add in send. Should have gotten an internal.
Alright. So you
Yeah. 0.0. There we go. I think this is the best possible system.
Because everyone sees it.
But I'm surprised. There's one very
Should it update right away?
No,
it'll take
it takes a while. Recall how we talked about blocks having to be accepted in the network.
So you have to wait for a new block to get appended to that again. And for
Okay, we'll wait a bit and we'll see. Do you have any experience spinning up side chains?
Hey, Kelvin, where did you post the? No, like the. Oh, it's okay.
I took it out because I didn't want to plug other channels. But
Oh, dang. Yeah. Okay. Does everyone who wanted ETH get ETH?
Yeah.
If you have not gotten ETH by this point, raise your hand.
yeah. And if you still need help with setup,
I'll be there.
Boy. No, I just
So earlier, we wanted to. Oh, no. Now, here you have 0.05. Switch. Depending on. Anyone else? Anyone else at all? It doesn't matter how easy it is or how hard it is.
Can you take the link to do that in Ethereum?
oh yeah, sure.
Okay. That's okay.
Yeah.
This is probably the more.
Yeah, that's fine. Yep, just post it to Google Doc if anyone still wants it.
All right. Is anyone at all having trouble? Who has $11 worth of ETH now?
Yeah, free money.
Free money.
Free
Anyone
money.
else want free fake money?
If we put that in the description, I think more people would.
Yeah. If you don't, people get money. All right. Okay. Everyone set up. Let's all go to remix.ethereum.org. The link is also in the Untitled Chat in the Ethereum channel. So remix.ethereum.org.
Is it invalid address? I don't know if that's true.
No, not that one. Okay. Oh, there's more. Okay, let me.
Yeah.
I didn't realize there's a page 2. Sorry, guys. Anyone have any questions at all? No.
Yeah, you sent.
Is that a good one?
Yeah. I think one of them is it.
Okay. All right, guys. Hi.
So what happens if you were to send that fake ether to like an actual public address?
So your public addresses are actually all the same across all the networks. It's just that your address on the main network has 0 ether right now, but on Rinkeby it has 0.05.
Oh,
So does that kind of answer your question?
just like kind of like something on a server and your local host.
Exactly. Anyone else have any questions? So is everyone who is following along? Everyone is on remix.ethereum.org. Everyone's here? You don't need the part after the URL. Oh, hi. Yeah. What's up?
Who needed help?
Yeah.
What's up?
Yes.
Alright, so we also have this gist over here on GitHub. The link is also in the Hack the North chat under the Ethereum channel. I'm going to copy and paste this code, as all good programmers do. So copying and pasting the code in the gist over here. Copy and paste, and bam, you're a blockchain developer. It's good exercise. So I've just finished copying and pasting the code from Stack Overflow. So everyone got that? Everyone's here? Who's at this point right now? Is anyone having any trouble at all?
Yeah.
Okay.
If you need help, just raise your hand.
Okay, sure. I'm not sure if you guys can see this. All right, you guys see this over here? It starts to compile. We can click on that.
Here we go. Bam, bam. Oh, wait, no. Whoa. Okay.
All right. Everybody have a green storage here? Would be great. If you guys are having any trouble, just raise your hand.
Yeah.
I'll help you out.
Yeah, and then the code is here. So yeah,
Run,
we'll be going through it.
and then deploy. It's the red button.
Maybe do it again.
Okay, so one more time. We copy-pasted the code. Compile, compile. There should be a green thing here. Now we're going to go over to run and then deploy. Everyone following along? All right, who's ready to deploy their first smart contract, or your second, or your 50th? First. Good, everyone? All right, I'm pressing the button. You'll get a MetaMask notification. It costs 2 cents to deploy this contract. Okay, so if you've deployed this, if you pressed deployed already, then all you have to do is go over to MetaMask. You see that transaction for contract deployment over here. Click on that. You'll go to Etherscan. Etherscan is a website for basically digging into the blockchain and getting insights about it. You see it's a contract transaction, so it's the type of transaction that we talked about earlier that actually creates a contract, that uploads the code into the computer. And over here, you see contract address created. So now our contract, now our code that you just wrote has been uploaded into the computer. So you see this contract address. We're going to copy that. All right, everybody good? Anyone having any trouble? Raise your hand. Oh, yeah, let me do that again. So we're still in the IDE. MetaMask, contract deployment. Anyone else? Don't be shy. Yeah.
Come around if anyone else needs help. So.
Do we get a question? Yes, copy paste the address. We're going to do something with it. And it's like inside of
If you guys are having trouble pasting the code into the contract, on Slack I put the contract code, so all you need to do is just copy and paste that into the ID if the gist isn't working. So try that out. If the gist isn't working, it gives you like an API load error.
You make it go?
I put it into,
Oh, sweet.
yes, I put it into Slack.
All right, does anyone else have questions?
Anyone else need help? Oh, up there. Contract. Yeah? No? Hey, what's up?
He does, but we're actually, we don't have time to get to the chat. When you're looking at the chat, feel free to look at it on your own, but yeah, we're just going to do the smart contract stuff this time. So, yeah, sure. He's the guy who wrote it, so you should ask him.
Everyone good? Alright, if you wait 15 seconds, you should succeed in your account. Everyone good so far? Any questions? Alright, we're going to go to the next step for now, but don't worry if you're falling behind or like, any trouble at all.
Yeah, just raise your hand if you need.
Alright, so we're going to copy paste that address from Etherscan. It's this one. It says contract address created. This is your contract address. Now we're going to go over to this link in the Slack that we haven't actually posted yet. Give me 1 sec. We're going to open that up. Looks like this. And we're just going to leave it, and we're just going to copy paste our contract address in here for now. Oh wait, that's not the contract address. This is the contract address. So this value from over here on Etherscan, we're going to copy into here. Contract address code. We'll show you guys the source code for this app in a little bit. But yeah, let's move on with the presentation for now. Okay. So, where were we? So, congratulations, you guys. You just deployed your first smart contract to the blockchain. It's the fake blockchain, but if it was the real one, you would have just deployed a real smart contract. What's that? Okay. Yeah, okay. All right, so we're running low on time. Let's have some time for questions. Anyone have any questions? Anything at all? Doesn't have to be about this in particular. Just the technology.
Anyone have any questions? Trouble with setup?
Not bad. Awesome. Yes, you were there.
You could describe it.
Okay, so now that we have a little bit of time, let's go over limits. So we didn't really have time to go over the language itself, but basically this is a language kind of similar to C or JavaScript, if you're familiar with that family of languages. We're defining a contract. Let's see this right. We're defining a contract. And this contract has two methods on it. One is set, which sets that variable, and one is get, which gets that variable. I'm not sure what else to say about it, but these variables are actually Ethereum storage variables. So when you modify them in a contract, their new value is actually stored onto the blockchain, like permanently. And when you run the program, you can mutate these variables. You can say value equals new value, I don't know, like value equals 5. Oh, that's the caps lock on. You can do that too. You can do anything you want. The only limit is your imagination. Okay. Questions, anyone? One more thing. All right, cool. So let's take some more time. Okay. So we wrote a very simple dApp here. Very simple as in it doesn't do much. Here's the source code. It's a link at the bottom of this page that we posted in the Slack. It's a very simple. As I said, it doesn't do a lot, but it's an HTML page. Nothing special about it, and some JavaScript that runs on the page. And what this does is this JavaScript uses some objects that are injected by MetaMask extension into your page. So when you install MetaMask, this extension injects an object called Web3 into your current web page, every web page. And we're using it here, Web3 current provider. And then this button, when you click it, it uses Web3 to create a transaction and then publish it. But what it looks like here is you're just calling the set method. So contract.set here to do a set. We can also go over this afterwards, and we're available to chat about this as well. Did I see a question over there? No. Likewise, when we want to get something, we do contract.get, and we can just call that. So let's do a quick demo. There's a contract that I just deployed just now, copy pasted the address from here, pasted it in here. I'm going to set nobody saw that. All right, so let's say we get a value, like any random value, and then let's say we want to set value to 1, 2, 3, 4, 5. Like we want to set this variable to 1, 2, 3, 4, 5 on the blockchain. So we're going to go over here in this app. We're going to say 1, 2, 3, 4, 5, set value. This is an app that we wrote for this presentation. We're going to spend 1 cent changing this variable. 1 one fake send. And then we're going to wait 15 seconds for this transaction to go through. You can all make small talk while this happens. How's your day? Oh, no way. I'm doing a presentation too.
Oh, okay, cool. What's
That's right now. Oh, okay. Looks like it's done. Let's get the value. It's 1, 2, 3, 4, 5. Good work, guys. All right, that's our presentation. We did skip a lot of content. If you're interested, we'll still be using this afterwards.
And in the link, the onnews.ca link, you'll see in the demo app that there's also an extended version of our slides. They're a lot more wordy and a lot more verbose, so if you're really interested in learning more, that would be a good place to start.
They include a lot more information about the technology and how it works. So if you're on this page that you're looking at right now, onnews.ca, Intro to Web3, this has links to everything we talked about today, including the slides that you saw, the longer version, links to all the resources that we used today, code, and the speaker notes are also in the slides if you're interested in what we've been reading from. Pretty much. All right, that's our presentation. We'll be continuing after this, but if you want to leave now, I was going to say please do, but that's not what I meant.
Yeah. All right. Thanks, everyone.